guys, welcome to another lesson on Introduction to Ordinary Differential Equation. We are looking at another concept, and that is separable differential equations. Now, a differential equation is said to be separable if it can be written as m at x dx equals n at y dy. So any equation that can be written in this form can be said to be a separable equation, where this m at x is a function of x alone. So it means the differential equation will be given to you by the ability to separate the differential equation, where the x variables will go to one side with its differential attached to it, and then the variable of y will also be grouped to another side with its differential attached to it. That type of differential equation is what we refer to as the separable differential equation. Though there are several forms of differential equations, such as homogeneous differential equation, exact differential equation, and including the separable differential equation, and etc. Each has its technique used in solving it. So it is important to identify the type of differential equation before solving a particular differential equation. In solving a separable differential equation, you need to consider these important steps. The first step you need to consider is 1. You need to separate the variables. That is, rearrange the equation so that all the terms involving y are on one side and all the terms involving x will be at another side. Secondly, after the separation, you need to integrate both sides. Then thirdly, you solve for y if possible. If not possible, you leave it as that. And then thirdly, make sure you include the constant of integration. So these are the procedures in which we can follow to solve a separable differential equation. So now let's start with our first example. Determine the general solution of the following differential equations. And the first one that we are going to look at is x dy minus y dx is equal to 0. Solution. We're given x dy minus y dx is equal to 0. You can see clearly that this we can easily separate. You can separate the x and its differential from the y and its differential. So first of all, let's move this to the other side, and that will be x dy equals y dx. You can see clearly that if we divide both sides by here by x and here by y, we can easily separate them. So now, in separating, we are going to get, when the y comes here, we're going to get 1 on y dy equals, when divided by the x, we are going to get 1 on x dx. Let's integrate both sides. So let's integrate 1 on y dy equals 1 on x, the integral of 1 on x dx. So the question is, what is the integral of 1 on y? We know that is what? Ln of what? Y. Because when differentiate that, we're going to get the same thing over there. Plus, over here, we need to introduce the constants. Since there's a natural logarithm of y in it, that's a ln y in it, we need to bring in the constants of integration, that's a c. But here, we will put the c also as a ln, so that we can easily simplify where necessary. Equals ln x. Note, I can also choose to bring the ln x over here. So either ways that you want to, that's correct. So now we know from a logarithm that we can easily multiply this. So when we multiply, we're going to get ln this and this. When they are adding, we multiply the parameters. So we are going to get cy equals ln x. Since we have ln here, ln there, it means we can have cy equals x. Making y the subject, we're going to get y is equal to x on c. And that is our general solution. There's no any initial conditions given, so we leave the answer like this. Now, our second example, we have x, y prime equals 1. So let's look at how we solve that one too. In this problem, we're given x, y prime equals 1. You can see clearly that we need to convert this one to the dy dx form. So that is going to be y, xy, dy dx is equal to 1. Let's multiply here by that, and we're going to get xy dy is equal to dx. We can take this x to the side by dividing, because they are multiplying. So in that case, we're going to get y dy equals 1 on x dx. The separation has been done. Let's integrate. So integrate both sides. Our integral of y dy is y squared half the square you divide by the 2 over here, because ln of x plus ln c. As I told you, because there's a ln, we need to bring in ln c so that we can easily manipulate it. So we have half y squared equals this, and this will give us ln of cx. Taking out the ln, we'll introduce e to the power of whatever we have here. So that will give us c at x equals e power whatever we have at that side, half y squared, which we can choose to at least make x the subject, or we can also choose to maintain it like that. So our x is equal to e power half y squared on c. So we're given sec square x dy plus cosec y dx equals 0. So first of all, let's make sure we do the separation. We're going to have sec squared x dy equals negative cosec y dx. So we are going to get 1 on cosec y dy equals minus 1 on sec square x dx. So that's, we divided both sides by that, and that's what we're going to do. But we know that sine of a particular function y is the same as 1 on cosec y. We learned that cosec y is the same as the inverse of sine. So if we make sine the subject, you get that. And also, we also know that cos of an angle x is also the same as 1 on cosec of that angle. So if it is true, we can substitute that over there so that we make the work easy for us. So doing that, this will give us sine y dy equals, in this we are going to get negative cosine squared x dx. So integrating this, we have sine y dy, integral of sine y dy equals negative integral of cos squared dx. We get negative cosine of that function. We need to convert this to a form that we can easily integrate. So let me repeat it again. But we know from half angles that cosine square x is the same as half bracket 1 plus cos 2x. So we are going to get negative cosine y equals negative half the integral of 1 plus cosine 2x or dx. So now we are integrating the other side. Our half will be there. Integral of this will give us the parameter. Integral of this will give us x with respect to x, plus the integral of this 2 will give us half sine of the 2x. So we have cos y, then plus our constant c. We continue. We are getting, let's multiply through. So when you divide through by that, you're going to get, by negative, you're going to get y dx equals 3x dy. We have 2y dx equals 3x dy. You can pause the video to go through, then after you compare your answer with my solution. In solving, We need to divide both sides by this so that we can go. So we're going to get 1 on 3x dx equals 1 on 2y dy. So integrating, we're going to get 1 on 3 integral. I just brought the other one out. 1 on x dx equals, when we factor 1 on 2 integral of 1 on what? Y dy. So now let's integrate. This will give us 1 on 3 ln x equals 1 on 2 ln y plus ln of c. So can choose to multiply through by 6 just to get rid of the fraction. That's all. So when I multiply through by 6, I'm going to get 2 ln x equals 3 ln y plus ln c. And that's, I can put this one there, and that can give me this like logarithm. So this can go over there, and that will give me x squared equals the c times that will give me cy, and the y, the 3 here can be a cube. So that is the answer. Find the general solution of 1 plus x dy minus y dx equals 0. So 1 plus x dy minus y dx equals 0. So now let's do the separation. Let's move this to that side. 1 plus x dy equals y dx. So separating, we are going to get 1 on y dy equals 1 on 1 plus x dx. Now let's integrate. Integral of this, then the integral of 1 on 1 plus x dx. Ln y equals ln. So this one will get ln of 1 plus x plus ln c. Why? Assuming we are just solving that alone, you can say that let u equals 1 plus x. Then we differentiate the u is equals to, this will give us 0, this one will give us 1. So 1 of that will be the same as the x. So it means the x is equal to the u. So substituting, we're going to get integral of 1 on u, because u is like this. Then we know that our dx is the same as the u, so the u. So when you integrate it, you're going to get ln of u plus c, or plus ln c. Something like that. Then u was given as 1 plus what? X ln c. So that's why I wrote it straightforward that it's 1 plus x over there. So this means that our final answer is going to y equals this, and this will give us c out 1 plus x. So this is our final answer. Thank you very much for watching. Watch out for the part 2 of the general solution to separable differential equation. Thank you. Bye bye.